We should be live now. Running those two media pipes. So the CPU is doing extra work. We want to change the our one to be updated version. We want to add the body to it. Add the pose. Add a pose. Now create a posed object along with the face mesh. So MP face mesh. Max number of faces 1, that's okay. Minimum detection confidence. Yeah, that's probably why. Sometimes detecting my ear as a hand. I don't know, I can't see it on the screen, but let's add the pose. So we have hands as hands. This looks a bit scary. Right, format document. Okay, how do I change this? Just generate the whole code. That works with no errors. While it's generating, let me just pop the link to the stream just in case someone wants to join in. Put it on Twitter. I don't have much going on Twitter. Do have much going on LinkedIn. Wow, it's still generating. Don't forget to take a break. Post that quickly. Use 4 key. So this code is much longer. It has a pause as well. Landmarks. I don't know what's happening with the colors there. Okay, we'll have to stop this for a sec. We also need the name. So it's called the media pipe avatar. Media pipe avatar. Yeah, this one. Just call it number 2. Oh, wait, did we take the code? No. Copy code. Yeah, this one is the second avatar. I'll have to change that. Just check that the camera that's using the correct camera. It's using 0. No, it should not be 0. It should be 2. Did I say 2 to begin with? No, it was 0. Okay, now I'm confused. Well, avatar is using 0. So it should be second camera. That's my... Is that my body? Meant to be my... Face 2, select window, media pipe avatar 2. Share. Okay. It's meant to be mirrored as well, but doesn't matter. It's still mirrored, so it looks like they're talking to one another. Oh, probably not. Alright, does have... Yeah, it was good to could be good to have a neck. Can do a line dance. It's the elbows. It's the elbows in the frame. Which camera? Wait a sec. Okay, should we do just hand detection alone? Because it's obviously trying to detect the face and and body in that image. Yeah, because it could be nice if we could detect the whole lot. Just wait a sec, reposition the camera again. the best I do so far. Yeah, I'm trying to improve this avatar on the right, but I'm having lots of trouble doing that. Meant to be flipped. No, it's not flipped anymore. Why it's also a bit jumpy when it can detect my face sideways. This camera meant to be wide angle. This camera meant to have a wide angle. Is it actually being used? Let's see what the bot says. Yeah, I don't actually know what's the height and width. And I don't want to check it because it probably will stop working altogether. Do we do cap set at the moment? No. It's a good question. Yeah, we might move on for now. We actually were doing this turning EEG into music. If anyone is interested. So we already had something working. I had a fairly complicated file structure for it. Wait, I'll have to close this one so I can actually use the Visual Studio Code. Yeah, I have a bit of less CPU is being used, which is great. Just move my face a bit. Yeah, this one has only hands and no body. I was trying to add body and other things, ears, whatever. But yeah, so far just gulping power, CPU usage, and not much better than this one. Right, so doing this EG to music, and we had an index HTML JavaScript code for it that we generated yesterday, and this Python, there are a couple of Python scripts. There is a load data filter EG music conversion and run by. So this one should actually display the raw data like that. And so that's working okay, except it being a bit too slow for my liking. But we will deal with it later. The main thing is to get the music going. So this is pre-recorded EEG from many years ago. Should be a very high quality EEG, so there's no doubt this is actually EEG and not artifact. So there should be very little artifact from in this signal. Well, mainly because it was recorded directly from the brain. It's an implant, so it was recorded directly from the surface of the brain, and this is an epileptic seizure in it. It's 16 channel recording, so grid arrays, intracranial EEG. Should mention the source of the data. Don't forget to mention the source of the data. It's coming from, yeah, same data as this one. We can copy this line from spectrogram. Let's do it now so we do not forget. Okay, spectrogram. Because we have a bunch of tools on the website that's using the same data set. Pop this in the chat. So in index HTML. No, that's an old one. We need the one in templates. Index should have the source of the data at the moment, at the bottom somewhere. Yeah, this one here. And let's pop this in the bottom as well. Let's refresh this page. Right, this is better. Right, and next thing for us is sorting out the music conversion bit. I'm actually using the filter. I don't think this is working. And this is filter by. Should we start a new chat or continue with this one? What do you reckon? Yeah, we had a couple of errors that we were able to sort out. Yeah, I'm pretty sure this filter EEG is not actually being used. But how about we try to do the music conversion without any filtering first? Music conversion. Yeah, it started giving me some generic stuff. Might start a new chat quickly. Already half an hour. Wasted half an hour. Okay, we have index HTML. And then we have JavaScript. What's that for? Okay, don't need to explain it to me. And we have run by. That's what meant to pull it all together. Don't need to fix anything yet. We would want to fix the music conversion and then actually use it and run by. That's what we want to do, so you can stop generating. Yeah, this one, the music conversion. Okay, we actually don't have that problem anymore. Wait. Let's try this again. Because that problem we fixed last time, that was a simple fix. Yeah, we want to fix the whole file, the whole code, functionality wise. Need to somehow import data into it and convert it into music using MIDI, which is a library for working with MIDI messages and ports. Okay. Well, working with MIDI files, the music files. Okay, scale above a bunch of suggestions, time delays between notes, velocity, musical and rhythm, handling extremes in EG data, error handling, documentation. Okay. What is it currently doing? Taking minimum, maximum, generating notes, saving into output file. We want to test the output file. What is the output file? Okay, so output file should be in this folder, music output, derivative. Output files should go to this folder. How to change the code. And then from that folder, I want it to be played in the HTML. When we say music, yeah, it's overstatement. Should be just called noise. So just translating EG into sound. We don't know if it will sound like music or not, probably not, but we want to see if potentially seizures sound more like some sort of drumming music, maybe. Okay, so we have the converted to music, output file, none. What? Why? Okay, we already have that over there. Where's the folder? Output. Okay, I get it. So this default no name. Everything else is the same. Put file. Can't understand what it's doing. Okay, do I need to use it in run by? To use in run by. Okay, run by the Flask OS. Music conversion, we already have it. App static, that's fine. Okay, convert EG, start, load data. So loading that again, that's okay. Okay, so we don't need to do it over there because the folder is already specified in the convert EG function. So we can replace convert EG to music with that. How to play the music in the HTML. Okay, how to change the HTML to play the MIDI file. There's a MIDI JavaScript. What are the sound fonts? Okay, we need to learn about music now. You can host the files on your server or use CDN. The instrument set to default instrument, such as acoustic grand piano. That's nice. Update the file. You need so it can be hosted on your server. need more information on this one, obviously, because I don't have those files. Any inbuilt files? Okay, this wouldn't work with soundphone.downloads.com. Okay, suppose then static. We need the sound font folder, and apparently, okay, which has lag. No, there's a 404. It's just making stuff up, or can I search this thing? Sound fonts. Okay, making stuff up, aren't you? You made this website up. Should I mention it to you? These are not working links. Okay, now you're actually doing a search with Bing. Okay, this is on archive.org. Sound fonts collection. Do we need 500 though? Probably. Was it 36 gigabyte? Can I just download one? Someone's already asking for it. To download just one. That's not possible, is it? Would I have any installed on my machine? The file name is meant to be SF. Those are SF arc. XML. What? SF arc. Quite large, some of them. What's an SF arc? It's a compressed sound font. Okay, this will require another software. Should have guessed it's SF arc for archive. Okay. Can't really use them, can I? Is there a CDN with SF files? I don't like this other websites. Archive.org is okay. Just search archive.org. Yeah, want uncompressed. What's this called? Yeah, meant to be an audio file. I could use any file, use a CDN. MediJS CDN. Okay, well first we need to change the code. How quickly can we do that? So that's just the MIDI.js. I assume that's for playing the file. So we need to add that one. Modify control the HTML button play MIDI. We already have a play MIDI button, but wait, how does the file? This is what we have so far. This one is playing MP4s. Should we convert to MP4? I mean, MIDI should be more native, more suitable for music, is it? Didn't find any CDNs. It did. GitHub IO. Okay, can I use this one? Let's go with this CDN. Change HTML script. Okay, we have the mini.js library, including the HTML. That's fine. Add MIDI playback button. Where do we want the button? Okay, let's put it over here. Okay, we have play G music button. Add the MIDI initialization playback script. And why first, why is it not in a separate? Why is it not in a separate JavaScript? That script after over here, can we? Can we get an error? Yes. Still at the channel undefined. Why? we play and nothing happens. Okay, I want to move this into JavaScript, main JavaScript file. Okay, reached the current usage cap for GPT-4, even though we're paying for it. Haven't happened for a while. I wasn't really leaning on it heavily. Just came after a break, so I'm not sure. It's meant to be a moving window, something, but it's obviously not. There's something weird going on, but then the good thing is I can continue. The time penalty is only short, because it says I can continue with the default model now or try again after 12:41. Now it's 12:37, so it gave me a timeout of what, 5 minutes. Okay, so we need another 5-minute break. While we do the break, yeah, I would just like to talk about something else quickly. My face. Over there for a sec. Yeah, I want to talk about this. So this is my current understanding of a simple neural network. This is done in LabVIEW, a back diagram. I used LabVIEW for many years, so that's what I'm used to see. Now, interestingly enough, popping it into GPT-4, it's able to explain what is it we are looking at. So it says the image you have uploaded appears to be schematic representation of a simple neural network. It's a neuron model used in machine learning, artificial intelligence. Yes, yeah, we know that. It shows the basic components of a neuron, including inputs, weights. Yeah, just can read text, that's fine. Bias, activation function, in this case a sigmoid function. So must have just read that title. And the output, by the way, yes, in LabVIEW, by default, a function like that will not have a title, so go figure what it actually, what this one actually means. That one is also not absolutely clear, but all the rest is very straightforward. Not sure why not just use simple math equation instead. So it's giving a brief explanation of each part. You have the inputs to the neural network, the weights. Yeah, it's explaining, giving a general explanation what weights are. A bias akin to the intercept in the linear equation, and is used to adjust the output along with the weighted sum. Okay, and then the sigmoid. So this is a type of activation function that is commonly used in neural networks to introduce nonlinearity to the model. Okay, it maps the input values to an output range between 0 and 1. Fine. And the output is the final output of the neuron after the weighted inputs have been summed with the bias and passed through the sigmoid activation function. Okay. And it does recognize that this is actually LabVIEW, because it says the layout and visual style suggests it might be created with a specific software for educational or simulation purposes, possibly something like LabVIEW. Okay, it's not entirely sure, but yes, it is LabVIEW, which is often used for creating simulations of systems and control models. Now, if you used LabVIEW a lot, you'll be familiar with this, yes, but most people have no clue what LabVIEW even is. So can GPT-4 translate this LabVIEW backend into maths, which is way more common? And yes, surprisingly, well, not surprising, I don't know if it's surprising or not, you let me know in the comments, but apparently yes, it can. So this seems to be a legit equation, looks much neater, much nicer, quicker, one line. Yes, you know, you need to know what each component is, but there is a quick explanation. Out is the output. This one is represent the sigmoid activation function, and there's a separate definition of a sigmoid activation function, which is a standard textbook equation of a sigmoid function. This bit represents the weights corresponding to each input. That bit represents the input itself, and plus the bias is the bias, and n is the number of inputs. So pretty straightforward. I'm not sure if you can get this much information from the above LabVIEW backend. Not that great, and gives you a summary as well. Oh, sorry, it also says that the sum inside the sigmoid function is a dot product, yeah, sounds legit, of the weights and inputs, which when added to the bias term yields the neuron's total input. The sigmoid function then transforms this input into the output between 0 and 1, which is the final output of the neuron. So that sounds great. One note though, that sigmoid function activation has all sorts of problems with it. So if there are many other different models that are worth looking at. And the more if continuing further, GPT-4 is able to translate this into Python, which, and again, I used LabVIEW for many years, but this Python looks pretty straightforward. It has the basic equation for the sigmoid, much simpler than the LabVIEW thing. Pop it in here somewhere. So GPT-4 is also able to convert the maths into Python, which, even though I've been using LabVIEW for years, Python code is much cleaner, more straightforward. It actually shows you what inside this box here, what's inside the sigmoid function, has the dot product for the weighted sum plus the bias, and returns the sigmoid function on the weighted sum. Then you can have your inputs, weights, this defined as whatever you want, set your bias, and off you go. You have your output. So really, this equation here is just these 3 lines of code. This bit here doesn't even show you what's inside the sigmoid function, which could be again another very simple equation for all this bit. Interestingly, when asking GPT-4 to generate LabVIEW code again, it generates this wicked image that means absolutely nothing, unless maybe it means something to someone else, not me. Let me know in the comments. But yeah, so ChatGPT was able to translate this image into simple maths, which is the gold standard, the absolute most common thing that most people are familiar with. There's nothing overly complicated in this equation. Sum, dot product, and a sigmoid activation function that has a separate equation. GPT-4 is able to translate this equation into Python in a very straightforward way. That's probably because there's many examples on GitHub and other websites. Not able to translate back into LabVIEW. I was kind of surprised it was even able to recognize LabVIEW code, which was quite interesting. So this example must be sitting somewhere on the web on which the image models were trained as well. So there you go. Let's close this. Might eventually turn something similar into a web application, a Flask web application, more likely. This is mainly so I can learn more about a simple neural network. Well, with a single neuron, but we can go from there. Right, so back to EEG into music. So reached. That says try again later. Is it because the time? Okay. So now it's working still on GPT-4. Still trying to figure out how that timeout works. Okay, we already have file name path to main.js. Guess we can get rid of this script over here, and the main.js load plugin. Where does it go? Let's just sit anywhere, or okay, sorry, that was wrong. Oops. This is main.js. Okay, now we're bombarding GPT-4. Before, I don't know how I got the time on. I was pretty light on the pedal, I thought. Okay, so the MIDI file. So we're using acoustic grand piano. Hopefully that works. I don't actually know. On success function and player. So this MIDI file should this stuff just be in the static folder? I'm not sure. A copy relative path. And the mid file should be in this folder. There's nothing there at the moment. So in main.js, in a quick update. Should be the same function MIDI player. Yeah, this should be a relative path. Because we're already in music, so it should be just like that. File naming. It's loading. It's loading forever. Control F5. Yeah, music MP3 is not there, that's okay. Hey, where's the data? Right, there's the data. And nothing happens when user presses the button. Need to change quite a few of other things. Okay, in main.js, HTML, we have the button. Okay, play MIDI. Document get click function. That's correct. Let's double check this one as well. No, this is the same. So first of all, on loading the page, we're having a problem. So when we select a different channel, the data is actually being displayed. When we hit play, play G music, nothing happens. Why? Okay, this is the music conversion. There is something wrong. How do we know the JavaScript is supported? Okay, well, the main problem is that we don't have anything in music output. Add this folder. is empty. It's the output file. Yeah, it should have that file in it. Let's do some error handling. So where is it being called? This is where the function is in runpy. Right, should we had to have the file name in there, did we? I don't know why it doesn't just display the thing on loading. There's nothing in music output. Yeah, we're not expecting to have the MP3 there. Guess something is wrong. Can we do can we print those as well? If there's no output file, create one. I'm already doing that. The file track. That's the same. Then we do this instead. Let's clear this. Run this with Control F5. Yeah, we're getting an error on loading. We have to select the channel. It's actually doing something. Again, when pressing this button, nothing happens. It's not actually getting past data image. It's not being called correctly. Yeah, this bit. We're not doing it properly, do we? We're not calling this function anywhere. Is convert to EG music. There's something wrong with this code. How to fix? It's not working. It's not actually running at all. There's a problem with MIDI.js. It's CDN.js. Not found. Mate.js 78. At this bit. That Cloudflare CDN is not working. None of them are far. Are you giving me fake giving me fake links? GPT-4. Yeah, this one has some uncompressed sound fonts. A mini.js not found. There's nothing there, is there? Okay, there's something. It's jQuery. Doesn't have the MIDI JavaScript. Okay, should we? Would converting to MP3 be easier? Or wave files probably be more like it. So obviously this one. Yeah, MIDI. Well, even if it works, be having trouble playing it in the browser. Okay, I'll try wave files as well. Just something easy to convert the EEG into, should be easily convertible into wave file. Okay, we might continue this next time. See you later. Don't forget to check the website. Don't forget to check the website.